Okay, while we are discussing about the Bohr theory for hydrogen-like atoms, so this is applicable for a single electron when revolves around the nucleus. It is having position. So this expression is important. Rn equivalent to n square h square epsilon naught by pi n e square z. So after that we will see. After taking all the required values, we get Rn equivalent to 0.529. Nearly we will take that 0.53 n square by z angstrom. N square by z angstrom. So therefore, finally, what is our conclusion is for hydrogen-like atom, Rn is proportional to n square by z. Suppose if n1 is equivalent to 1, if n1 equivalent to 1, we will take R1 equivalent to 0.53 angstroms. So this is called as Bohr's radius. This is called as Bohr's radius. And that particular orbit called as Bohr's orbit. Bohr's orbit here. So after learning about the radius, we are focusing on velocity of electron, in nth orbit, velocity of electron in nth orbit. So from the formula mvr equivalent to nh by 2 pi, we will take vn equivalent to nh by 2 pi m into rn. And also just now we have studied Rn equivalent to n square h square epsilon naught by pi n e square z. So finally, we are going to get Vn equivalent to e square by 2h epsilon naught into z by n. But for our convenience, we are modifying it into a form e square by 2h epsilon naught into c into cz by 9. We are calling that e square by 2h epsilon naught c as a constant. So Vn equivalent to alpha into cz by cz by. So here alpha is it is called as fine structure constant. So this is fine structure constant. So this is nothing but e square by 2h epsilon naught c. So that equivalent to 1 by 137. So the value is important. So finally, what we have to remember is Vn equivalent to 1 by 137 into Cz by n. Cz by n. So this is very important. So remembering of this equation is also very important. Vn equivalent to C by 137 into Z by n, like that we will remember. So finally, what we are concluding is Vn is proportional to Z by 1, Z by n. Vn is proportional to Z by n. So after that, taking of velocity, now we used to think of angular frequency or velocity. Next, angular frequency or velocity. So both are same. In some topics, we may call it as angular frequency, and in some topics, we may call it as angular velocity. So then we will take omega equal to V by R. So Vn by Rn. So by substituting the values, required values, we will get pi m into e power 4 by 2 epsilon naught square into h cubed into z square by n cubed. So finally, we will remember it as omega n is proportional to z square by n cubed. So these equations are really important. So while we are doing some problems, omega n is proportional to z square by n cubed, where z is the atomic number and as well as n is the principal quantum. Or else we know that frequency is equivalent to omega by 2 pi. Okay, and also from there we will write Fn is proportional to z square by z square by n cube. This Fn is nothing but this is the frequency. So when we think of time period t, time period t equal to 2 pi by omega, that is inverse. So therefore, time period Tn is proportional to n cube by x square. This is very, very important. We have theory questions on the basis of this equation. So the remembering of time Tn is important. Tn is proportional to n cube by z square. So after taking the time period, we are thinking that so whenever the electron revolves in circular orbit, when the electron revolves in circular orbit, generates electric current I. So now we are going to find that I equivalent to Q by T, that is E by T. So therefore, finally what we will remember is, already we know this, I is proportional to 1 by T, nothing but frequency. So that is z square by n cube, z square by n cube. So but the upcoming thing is very important, magnetic moment. This is very famous also. Magnetic moment. In some previous questions, you are having direct the principal answer. Magnetic moment of electron. So magnetic moment of electron means its formula is Mn is equivalent to N into EH by 4 pi M. EH by 4 pi M. This is very important. The remembering of this equation is very important. Because in this equation, the people generally forget about the Bohr magneton. So that is important. So here I am taking EH by 4 pi M. EH by 4 pi M is called as Bohr magneton. So therefore, Mn is proportional to N. Mn is proportional to. So actually, we have a trick. Easily remember this formula. Mn is proportional to N. So generally in the moving charges, we will study a formula when a charged particle revolves in a circular orbit. So there we will study m by L equivalent to q by 2m, charge of the particle by mass of the particle. But actually these two things are constants. These two things are no way depends upon principal quantum number. So simply we can remember like this, m is proportional to L. Angular momentum, already we know that L equivalent to ns by 2 pi. So therefore L is proportional to n. So easily we can remember this. This is very important. So whenever the electron revolves in circular orbit, it will generate a current. So that means it is going to develop some magnetic field at the center. Of. So what is the magnetic field at the center of atom? So generally, for the circular coils, we are taking mu naught I by 2. This is a formula we will come across in moving charges and magnetic. So that is proportional to I means q by t. Mu naught by 2 is a constant. I means q by t into r ampere. Q means charge EV by r square. So by substituting all the required values, we will get B is proportional to Z cube by 10.5. So V is already, we know that C by 1% Z by N. R is proportional to N square. So by taking all the desired values, so we are going to get the equation as B is proportional to N cube by Z power 5. So next, the most important thing is kinetic energy. The most important thing is so kinetic energy is equivalent to half mv square, half mv square. We know the formula mv square by r equivalent to 1 by 4 pi epsilon naught into 2z square, 2z square by r square. Just to bring that to right side, half mv square equivalent to, we have z square z square by 8 epsilon naught here, z square by 8 pi epsilon naught. So simply with the help of that equation, easily we can remember kinetic energy is proportional equal to z square by 8 pi epsilon naught r. అంటే ఇవి టాపిక్ లో ఫార్ములాస్ అంతగా గుర్తుండవు బేసిక్ గా. సో అందుకోసమే మనము సింపుల్ గా ఎలా గుర్తుంచుకోవాలనేది. సో ఫ్రమ్ దట్ ఈక్వేషన్ we will easily remember. Suppose here we will conclude that the kinetic energy is proportional to v square. Already we know that v is proportional to z by n. So therefore, kinetic energy is proportional to z square by n square. So easily we will remember in the terms of z and n. Next, we used to think of potential energy. Potential energy. So potential energy means we will write here potential energy U equivalent to, just by taking of electrostatic formula, we can easily remember 1 by 4 pi epsilon naught q1 q2 by r. 1 by 4 pi epsilon naught into q1 means ZE, q2 means charge of electron is minus e by r. So in that way, we can easily memorize the formulas. So the remembering of formulas is very important. So remembering of formulas is very important. So by using this, we can easily remember the formulas. So next, I'm taking total energy. Total energy. So total energy equivalent to kinetic energy plus potential energy. By combining these two, we get minus ZE square by 8 pi epsilon naught r, minus 8 pi epsilon naught. So again, after taking the value of r, so finally we get E equivalent to, we used to call the total energy as E. This is very important. Minus RCH into Z square by N square, where we are calling R is the Rydberg constant. R is the Rydberg constant, that equivalent to Ne power 4 by 8 epsilon naught square CH cube. Its value is nearly 1 into 10 power 7 meter inverse. Meter. So again, by substituting all the desired values, so finally we are going to get E equivalent to minus 13.6 into Z square by N square electron volts. Minus 13.6 into Z square by N square electron volts. So in this way, we will say this is very, very important. Very, very important, the total energy expression. And of course, in some typical problems, this expression for the Rydberg constant also important. Rydberg constant expression also important. Generally, we will come across 1 or 2 questions basis on Rydberg constant values. Okay, here minus 13.6, minus 13.6 electron volts is the total energy. Is the total energy. Is the total energy of electron in ground state. In ground state of hydrogen atom. Ground state of hydrogen. So finally, this relation is important. Potential energy. So potential energy to kinetic energy to the total energy equal to minus 2 is to 1 is to minus 1. Generally here n equivalent to 1 is called as ground state, and n is greater than 1, they are called as excited states. Excited states. Here the theories are very important. Suppose if somebody asks about when the electron jumps from lower to lower to higher levels, higher energy levels. So what happens to the nature of velocity? What happened to the radius? What happened to the total energy and potential energy? They will ask. So first we think of the relations. So later we will discuss this. V is proportional to 1 by n. We know that R is proportional to n square, and total energy is proportional to so that is in terms of negatives minus 1 by n square, and the potential energy is also is proportional to minus 1 by n square. Potential energy also we are having minus 1 by n square. So now we will discuss. So when the electron jumps from lower to higher levels, n increases. So n increases means automatically velocity decreases. When n increases means the radius of that circular path also increases. So this is very important. When n increases, okay, the negative value decreases. Negative value decreases. So therefore, the total energy value increases. The total positive value is increases. So in this also similar. When n increases, so negative value decreases. Negative value decreases. So therefore, potential energy also increases. Okay, and this is also important. E is proportional to 1 by n square. E is proportional to 1 by n square means as n increases, energy gap, energy gap between successive levels, decreases. Between successive level decreases. And at infinity, the total energy of electron becomes zero. The total energy of electron becomes zero. So the following values are very, very important. They are very precious. So because if we know those values, we can do problems very quicker. Otherwise, we will be in trouble. Suppose I am taking here, this is the ground state. And next, we are taking the first excited state. This is the first excited state. Next, we are taking the second excited state. This is the second excited state. Second level or first excited state. This is the fourth level or third excited state. This is the fifth level. And this is the, let us say, this is the infinity. The last one is infinity. So the last one is infinity. This is the infinity level. So now we are going to see the respective values. We will call this is the n equivalent to 1, and also we will call this n is equivalent to 1 means ground state to use. So ground state means we will write the values minus 13.6 z square electron volt. And whenever n equivalent to 2, so we call this from this onwards we used to call excited states. All these levels are excited. So that is important. Excited states. Everyone is excited states except the ground state. N equal to 2. So for n equivalent to 2, we are having minus 3.4 into z square electron volt. If n equivalent to 3, we have minus 1.51 electron volts z square. If n equivalent to 4, minus 0.85 electron volts z square. If n equivalent to 5, minus 0.544 z square electron volts. So generally these are the discussions. So we are taking n equivalent infinity. When we take n equivalent infinity, so that is of 0 electron volts. So these values you have to remember. These values you have to. Suppose here we know that minus 13.6 electron volts is the uh, energy of electron in the ground state of hydrogen atom. And here, therefore, plus 13.6 electron volts is called as the ionization energy, first ionization energy. Only we are having single electron as the ionization energy of hydrogen. Ionization energy of hydrogen atom. Suppose in the same topic, if somebody asked about binding energy, so when we think of binding energy, so we will write minus total energy. Binding energy equivalent to minus total. Okay, minus total energy means we will write simply 13.6 electron volts for the ground state here. For the ground state. Next, we are going to see a formula regarding the frequency of emitted radiation. Emission of radiation. Emission of radiation. So we know that when electron jumps from higher energy level to lower energy level, higher energy level to lower energy level. So we know that E2 minus E1 equivalent to H nu, or H nu equivalent to, we know that value 13.6 into electron volts into 1 by n1 square minus 1 by n2 square into z square here. So finally we are going to get some equation. Mu bar, this is called as wave number, 1 by lambda equal to r into z square into 1 by n1 square minus 1 by n1 square minus 1 by n1 square minus 1 by n2 square. This is a very important equation. So this is a very important equation. Suppose here mu bar is called as wave number. So now I'm taking a problem. Suppose calculate the angular momentum. We calculate angular momentum of an electron in Bohr's hydrogen atom, whose energy is minus 3.4 electron volts. Whose energy is minus 3.4 electron volts. So energy is given as minus 3.4. So just in the previous discussion we have taken that minus 3.4. Minus 3.4 means simply we will take n equivalent to 2. So if you know these values, so the problems will become very, very simpler here. So already by analyzing this minus 3.2, so simply we will say that n equal to 2, n equivalent to 2. And we will write a angular momentum equal to ns by 2 pi. So that equivalent to 2h by 2 pi. So that equivalent to h by pi. That equivalent to h by pi. So if we know that values, those energy values, we can do the problems directly without any hesitation. So I'm taking another one. For example, an electron in hydrogen atom, is in a state of binding energy 0.85 electron volts. The electron makes a transition. To a state of excitation energy. 10.2 electron volts. Calculate the energy. Calculate the energy and wavelength. Of photon. So first we will analyze the problem. Binding energy is 0.85, means I'm taking the total energy to equivalent to negative binding energy, that equivalent to minus 0.85 electron volt. So whenever we see minus 0.85 electron volts, simply we will say that N2 is equivalent to 4. From N2 equivalent to 4 to, it was undergoing a transition to a particular level, whose excitation is 10.2 electron volts. So that means, so whenever the electron is in ground state, so that is it was possessing an energy minus 13.66 electron volts. So if you provide an additional energy of 10.2 electron volts, so then the electron is going to occupy in this particular orbit. అంటే గ్రౌండ్ స్టేట్ లో ఉన్న ఎలక్ట్రాన్ కి 10.2 ఎలక్ట్రాన్ వోల్ట్స్ అనే ఎగ్జైటేషన్ ఎనర్జీ ఇస్తే అది ఆ లెవెల్ కి వస్తుంది అని అంటారు. సో therefore I am taking E1 equivalent to minus 13.6 plus 10.2. So that equivalent we are having minus 3.4 electron volts. So from this we will say that N1 equivalent to 2. So now the problem is very easier. So we can calculate the energy. So we will take E2 minus E1. So that equivalent to E2 minus E1 means minus 0.85 minus of minus plus. So that is 3.4. You are going to get 2.55 electron volts. If you need the wavelength, already we have seen lambda equivalent to 12,400 electron volts angstroms by, we will take delta. So 12,400 by 2.55 means, so that equal to 5515. So in this way We will do problem. So we are taking hydrogen spectrum, so which is known to us very well. Hydrogen spectrum, emission spectrum we have been taking. So generally we are taking mu bar equivalent to 1 by lambda equivalent to r into z square into 1 by n1 square minus 1 by n2 square. Suppose if the electron be excited to, if the electron is be excited to the first level, so that is n1 equivalent to 1 and n2 equivalent to 2 comma 3 comma 4 up to so on. If the electrons are de-excited to first level, we will get Lyman series. So the specialty of Lyman series is it is visible in UV region, and this is the only series which is present in emission spectrum and as well as absorption spectrum. It is present in both spectrums. It is present in emission and absorption spectrum. Suppose if you are taking n1 is equivalent to 2 and n2 is equivalent to 3, 4, 5 and so on. So we will get Balmer series. So we will get in visible region, only emission spectrum is present. And similarly, if n1 is equivalent to 3 and n2 is equivalent to 4, 5, 6 up to so on, we will get Paschen series. So this is present in near infrared. If n1 equivalent to 4 and n2 equivalent to 5, 6, 7, so we will get bracket series. So this is called as middle IR. And if n1 is equivalent to 5 and n2 equivalent to 6, 7, 8, we used to take this as fun series. So that is for IR. Okay, so these are the possibilities. Here we have one beautiful formula, that is the total number of possible spectral lines. So we are taking the formula for possible number of spectral lines. So between the two energy levels I'm taking. For example, this is N2 and this is N1. Of course, we have number of levels present between N2 and N1. So then we think of the number of possibilities, the number of all possibilities. So possible number of spectral lines is simply we will remember it as n into n plus 1 by 2, where small n equivalent to n2 minus 1. So easily we can remember this. But in this topic, the most important and as well as some kind of most confusing is recoil speed, recoil momentum. So that is very important. Recoil of an atom, due to electron transmission. So we are taking the first one. So while we are taking when the atom, so let us say we are thinking of hydrogen atom of mass m, of mass capital M is fixed and emits a photon. So we know that that is 13.6 into electron volts z square into 1 by n1 square minus 1 by n2 square is equivalent to. So this is equivalent to energy Hc by lambda of photon. This is very well. This is very known to us. So that means while what is the conclusion of this discussion is, while it emits a photon, while it emits a photon, so we are treating that the hydrogen atom is fixed. We are not thinking of any recoil. We are not thinking of any recoil. So slowly we will consider the situation where we are having recoil. So to understand that, so we are discussing the previous case also. For example, I am taking when hydrogen atom initially at rest, initially at rest. Now it is free to move. If it is free to move, if it is free to move, then what happens is the entire energy of the photon, it is going to be shared between the two. Then entire energy, entire energy entire energy equal to energy difference, entire energy which is equal to energy difference of two levels. Now it is going to be distributed. Now it is going to be distributed between photon, photon and hydrogen. So that means initially the hydrogen atom, we are taking only the hydrogen atom of mass here. This is the hydrogen atom. So this is at rest. But later it is free to move. So when it emits a photon is emitted like this in the forward direction. So then the remaining hydrogen atom so used to recoil. Recoil means it tends to move in backward direction. It recoils in backward direction. So in such a discussion, I'm taking if the photon have a momentum h by lambda dash and the hydrogen having a moment mv, so we are writing initially both are at rest 0 plus 0 equal to mv plus h by lambda dash or mv equivalent to minus h by lambda dash. So when we think of negative sign as the direction, we are taking modulus of v. Modulus of v is equivalent to h by m into lambda dash. M into lambda dash. So in this case is very important, and also we will apply law of conservation of energy. So by applying law of conservation of energy, so after recoil, if the hydrogen atom recoils with a speed v, so the final energy half mv square plus hc by lambda dash. It came through the energy difference. It came to the energy difference. Just now we have seen. So the energy difference will be shared across both hydrogen atom and as well as photon. But here our consideration is as the mass of hydrogen atom, as the mass of hydrogen atom is heavier, then its recoil speed v square can be neglected. So that means v is less, so therefore v square can be neglected. This is very important. Hc by lambda dash equivalent to delta E, we are taking. Hc by lambda dash equivalent delta E. But from the past relation, we are taking h by lambda dash equal to mv. So therefore mvc equal to delta E. Or else v equivalent to delta E by mc. V equivalent to delta E by mc. So this is very, very important. This is the recoil velocity. So V is called as recoil velocity. దీన్ని చాలా ఈజీగా ఎలా గుర్తుంచుకోవచ్చు అంటే E ఈక్వలెంట్ టు ఎంసీ స్క్వేర్ అంటాం కదా మామూలుగా, దీన్ని ఎంసీ ఇంటూ సి లాగా రాస్తాం. సో ఒక సీని నువ్వు వెలాసిటీ అనుకుంటే ఈజీగా సరిపోతుంది. సో at the end of conclusion of this atom, we are left with a little concern. So of course this is very important. Hypothetical Bohr model. hypothetical Bohr model. So hypothetical Bohr model means generally up to now we are taking that so because of attraction, electrostatic attraction, the electrons are habituated to revolve about the nucleus. Already we studied that function as U is proportional to 1 by R like that we are having. Suppose instead of taking that one, if the electron may follows another prediction like this. If the electron revolving around the nucleus, if the electron revolving around the nucleus undergo the influence of a new potential energy, which is not directly proportional to 1 by R. So they will give U as a function of R. So then how we will going to do the Bohr's model? That is the question. For example, I'm taking a problem here. Suppose if they provide U as minus half into mb square into R square. Suppose I'm taking U equivalent to minus half into mb square R square. Now they will ask that please you have to find out the velocity or radius like that. So we know that the Coulomb attractive force is a conservative force, and if we obey the rule F equivalent to minus du by dr. Minus du by dr means we need to differentiate that d by dr into u means we are taking minus half into mb square r square. So after taking the differentiation, we get minus mb square r. When we think of modulus of the force, we are having mb square by r. So that means వాళ్ళు ఇచ్చిన ఎక్స్ప్రెషన్ నుంచి u నుంచి మనం దాన్ని డిఫరెన్షియేట్ చేయాలి. f ఈక్వల్ మైనస్ du by dr చేస్తే మనకు ఎక్స్ప్రెషన్ వస్తుంది. వచ్చాక దాన్ని నార్మల్ అవర్ రొటీన్ ఎక్స్ప్రెషన్ తో కంపేర్ చేస్తాం. mb స్క్వేర్ బై r. u వాళ్ళు ఇచ్చిన దాన్ని డిఫరెన్షియేట్ చేశాక వచ్చిన ఫోర్స్ ని mb స్క్వేర్ బై r తో కంపేర్ చేస్తాం. సో బై కంపేరింగ్ దెమ్ వి విల్ గెట్ v ఈక్వల్ టు dr. తర్వాత మనకి ఎలాగో mvr ఈక్వల్ టు nh బై 2 ఫార్ములా తెలుసు. mvr ఈక్వల్ టు nh బై 2. So by substituting here v means br into r equal to nh by 2. So finally from there we get r equal to root of nh by 2 pi. So finally we will get v equal to root of nh by